ICML 2026 did not reward one kind of progress. The outstanding papers point to 3 pressure points in modern machine learning, where a model faces uncertainty, how a sampler pays for accuracy, and who gets to control aligned behavior. The first surprise is the flexibility trap. A diffusion language model can generate tokens in many orders, which sounds strictly more powerful than left-to-right decoding. But reasoning often turns on one uncomfortable fork, such as therefore, since, or a branch in a proof. Autoregressive order forces the model to sample that fork while the uncertainty is still alive. Arbitrary order can fill the easy future tokens first, then return to the fork after the branch has already been decided. The apparent freedom has pruned the solution space. Just GRPO is the deliberately simple response. During reinforcement learning, it treats the diffusion model as an autoregressive policy, so the likelihood is exact and standard GRPO applies. At inference time, the architecture can still use parallel diffusion decoding. The second outstanding paper asks a theoretical version of the same question. Where does the system really need to pay? Diffusion samplers usually learn scores, gradients of log density, not density values. Previous score only guarantees still-paid polynomially for tiny target error. First-order rejection sampling, or FORS, changes that payment. It uses gradient-derived random variables whose expectation is the missing tilt. A random product then becomes the accept-reject coin, so the sampler behaves like rejection sampling without evaluating the density itself. The payoff is high accuracy with a polylogarithmic dependence on 1 over delta, while the score estimation error remains visible as a separate term. The important move is not a prettier bound. It is separating target accuracy from the oracle error. The outstanding position paper changes the question again. Alignment methods are often described as safeguards, but technically they are purpose-agnostic control levers. The uncomfortable question is not only whether we can align a model, but who defines aligned. The paper maps a 3-stage stack: pre-training filters, post-training preferences, and inference time controls. Each can reduce harm. The same lever can also suppress facts, steer viewpoints, or make information control look like normal safety behavior. Its mitigation frame is not to halt alignment research. It is to make control contestable, plural models, verifiable audits, public literacy, and explicit dual-use reflection before these mechanisms scale into everyday information infrastructure. Together, the winners give one design lesson. Strong systems are shaped by where they face uncertainty, where they pay approximation error, and who can set the objective. The right bottleneck should be exposed, not hidden.
更多演讲实录与文章已收录至雷锋网 ICML 2026深度专区，现已全面上线。专区不仅全面收录了重磅论文的工程化解读、专家前沿演讲，更将持续更新前方记者的第一手会议动态。扫描下方2维码或进入雷锋网 ICML 专区即可查看。